Chapter 3.2, Truth Tables for Negation, Conjunction, and Disjunction. So in this chapter, we're going to get into something called truth tables. So this is where we're going to take our symbolic logic, which we will see, here's a summary, again, of all of our connectives that we've learned. We're going to take these connectives, our way of turning sentences into symbols, and we're going to sort of write out a way to decipher the truth of any given statement based on whether or not we know the simpler statements that are given to us, the truth value of each of those. So, what is a truth table, though? A truth table is a table that breaks down a compound statement in order to determine whether it is true or false. So, here we have an example of a truth table for this compound statement, the negation of the parenthetical negation P or Q, right? I don't expect you to understand everything that's written here yet. We'll get to that, or how to build it at all. Just want to break down the pieces to this given truth table. The first column, the first columns, list each simple statement in symbolic form, then the list of possible combinations of truth values the statements could have. So here we have P, Q. We write down T or F to represent true or false, right? Now notice that I have P being true twice, and then false twice. This is so that we get every possible pairing, where both are true, P is true but Q is false, P is false but Q is true, and P is false and Q is false, where they're both false, right? Those are all the ways these can be paired up. So we end up needing 4 rows depending on any combination these statements could make. But if we had more statements, more simple statements, if there are more letters to the compound statement we're making, we might need more rows. So if we have 3 simple statements, if we have a P, a Q, and an R, then we're going to end up needing 8 rows, and we'll see examples of that later. Next, we have the following columns build outward from the basic statements, giving new truth values for these compound statements. So here, when I say build outward, again, we're going to get into the rules of building truth tables, but essentially, I start from my basic statements, and building outward gets me to the negation first, and then the connective or, and then all the way out to our final one, which is the negation of the parenthetical. So it's sort of like building outward in that way. So that the final column gives the truth value of the full statement, which I have highlighted in red just to sort of make it stand out. But in general, it's just whatever the final column is, that's going to be your answer to this statement. So we could say, depending on the original simple statements that are truth, I could then say, yes, if P was true and Q was true, then our whole statement had to have been false. Something like that. That's how we would read this. Okay, so let's break this down into its smaller parts. But first we're going to look at the simplest of these truth tables, which is just the truth table for the negation. So the negation, written again as tilde P and read as not P. Remember that if P is true, then negation of P is false, and if P is false, then negation of P is true, right? The definition of the negation was that it just gives us the opposite truth value. So in other words, on our table, which we only have one statement on this table, so I only need 2 rows, we would start with the true and the false. That's all possible truth values for P, and there's no Q here, so I don't need to think about the pairings that are possible. Then we just directly change it to the opposite meaning. So the negation of P would then be false, true, instead of true, false. So if P is true, negation of P is false. If P is false, negation of P is true. That's going to be true no matter what we're working with in our truth tables. Anytime we see a negation of a statement, it's just we take the statements column and change all of the trues to falses and all of the falses to trues. Next we have the conjunction, which remember is our and statement. P with the upside down V, Q. So P and Q is true only when both P and Q are true. Now, this is not something I'm just making up. This is how we use the word and. So you want to always think about, if you can't remember these facts that I'm giving us, just always think about, okay, well, when am I being lied to? In what situation would I be lied to? Or when am I telling the truth, right? So if I said, for example, I am wearing a green shirt and I have blonde hair. Okay, that's two false statements, right? So I have two false statements because I'm not wearing a green shirt and I don't have blonde hair. So and you would know, she's obviously lying, right? I'm obviously lying. That's false, right? That's how this works. If I said, I am wearing a green shirt, so that's false, and I have brown hair, that's true. But I am wearing a green shirt and I have brown hair. Did I lie to you? Yeah, I still lied to you because I'm not wearing that green shirt, right? So that's still false. Now if I said, I am wearing a gray shirt. Now that is true, right? And I'm blonde, but that's false. So I'm wearing a gray shirt and I'm blonde. Well, did I lie to you? Yes, I did, right? So I'm still lying. Now we finally get to the nice one. I am wearing a gray shirt and I'm a brunette. Did I lie to you? No, everything I said was true, and so it is true. Cool. That's how the and statement works. Is the only time that it is true is if both of my simple statements, or both of the statements coming into that conjunction, are true already. Right? The only time I didn't lie to you was when both ideas that I presented and then conjuncted with that and were true to begin with. Anything else, if any sprinkling of falsehood was in there, I'm lying to you. That's how the and works. Okay. What about the or? So here we have P or Q, which again, remember, is called the disjunction, not the conjunction. Oops, let me change that. That's the disjunction. The disjunction, P or Q, is read as, again, P or Q, we use this V symbol. P or Q is true when either P is true, Q is true, or both P and Q are true. So in other words, it's only false when both P and Q are false. So once again, we're going to start from our beginning true, true, false, false for P, and our Q is true, false. Like, this is generally the pattern that we make so that we get every possible combination of truth values for our P and our Q. This is going to be true no matter what. Like, this is how I will always start my truth tables with just P and Q, is with this pattern. So that's how you should think to do it. So we start with that, and again, we get asked, okay, when am I being lied to, right? So we'll go back to the example I gave before about my shirt and hair, right? Because those are kind of easy ones to verify. So let's start again. I'm going to start from the top this time. So here is, I am wearing a gray shirt and I'm a brunette. Right. So either, if I say, I'm wearing a gray shirt or I'm a brunette, you could say, did I lie to you? Now, I kind of said it weird because, again, we have this question about the exclusive versus the inclusive or, and technically both of what I said was true, but we're working with the inclusive or here, so we assume, yes, if everything I said was true, we're all good. This is a true statement. Then if I say, I'm wearing a gray shirt or I'm blonde, you would still say, yep, that's fine. At least one of those are true, so it's fine. So that's also a true statement. If I said, I'm wearing a green shirt, or I'm a brunette, yep, that's fine, because again, at least one of what I said was true. But finally, if I said, I'm wearing a green shirt, or I'm blonde, you'd say, well, no, you're not blonde, and you're not wearing a green shirt. So, none of what I said is true, right? So that one is false. So we get that there's this one special case. And that's pretty much going to be the pattern for most of what we go through in this class is you have to think about what is the special case. So the special case for the conjunction was when both are true, we get a true statement. Everything else is false. Special case for the disjunction is when both are false, we get a false statement. Everything else is true. And when we get to the if-then statements, we'll have a special case for those as well, etc., but that's for the next chapter. So, right now we have our ands, our ors, our negations, right? So we can start building more complex truth tables, but that takes a lot of steps, so bear with me here. I'm going to read through the steps, but then we'll get to an example. I will show the steps, etc., so these will come back. But first, we make a column for each of the simple statements, P, Q, R, etc., and include a row for all possible combinations of truth values for those statements. So remember, the ones we've seen so far were when we just had P, we had 2 rows. When we have P and Q, we end up with 4 rows to get all combinations. So, and I said before, if I had an R in there, so 3 statements, we end up with 8 rows. How am I getting these numbers? Well, essentially, it's just 2 to the n possible combinations. That's how it works out. So 2 to the first power is 2 when there's just P. 2 squared is 4 when there's P and Q. 2 cubed is 8 when there's P, Q, and R. Do you need to memorize that? No. And you're also not going to see more than 3 statements in a truth table for this class. So you don't really need to worry about that. But it's something to remember is you need to make sure you have enough rows to go with the number of simple statements being made. Okay, so once we have those, you identify if there are any direct negations of simple statements present, such as negation of P, negation of Q, etc. Not negations outside of parentheses, because we know negations outside of parentheses have special meanings. They're the it is false that, right? We just want to look at where is there just going to be a simple not added to one of those simple statements. We're going to create a column for each of those. Then we work our way outward from each set of parentheses, if there are any, reading left to right, just like when solving an algebra equation. So we create a column for each compound statement inside parentheses, such as P or Q. We create a column for any negated compound statement, such as negation of P or Q. And then we create a column for further combinations of parentheticals, such as negation of P or Q, and P and Q, R. So we would have had a column for this, a column for this, a column for this, and then finally a column for the whole thing, right? So we'd have first columns would be the P, the Q, and the R. Those would each get their own columns. Then in order, it'd be 1, 2, 3, and 4, the whole thing. So the order does matter here, because in order to analyze this and statement, I need to have the 2 statements that are on either side of that and already completed, right? That's what we're doing here. In order to use this or statement, I need to have a column for the P and the Q. In order to deal with this negation, I need to have P or Q done in order to negate it. So working your way outward, you just need to think about, do I have all of the information present to actually do the connection, right? Do I have the left side and the right side of this and? Do I have a statement to negate? Do I have a column for those so that I can work with the truth values for those columns? All right, then we continue in this way until the final column contains the entire statement. And once we have our column headers, this is literally just to get the column headers. Now we use the basic truth tables to fill out the truth values for each of these compound statements until we get up to the entire statement. So let's try it out. So here we're going to construct the truth table for negation of Q or P. So we start by making a column for each of the simple statements, right? And we have 2 simple statements here, Q, P. So we're going to have a column for P, we're going to have a column for Q, and again, remember that as I have said it before, I have a particular order I like to do this in. That is, P is true, true, false, false, Q is true, false, true, false. If you just remember it that way, you aren't going to forget any of the combinations, so try doing it in order when you do this, because I will always do it in that order. So we have true, true, false, false, true, false, true, false. Okay, the 2 simple statements, 4 rows, we're done. Next, identify if there are any direct negations of simple statements present, such as negation of P, negation of Q, etc. So negations not outside parentheses. Direct negations look like this, right? So this one is outside parentheses, so we're ignoring it for the moment. So we get a column for negation of Q. Next, work your way outward from each set of parentheses, if there are any, reading left to right, etc. So we would start with, we've got the negation of Q, which means we have negation of Q, we have P, so we have the 2 things on either side of this or. So that or is going to come next, followed by, now we have everything that's inside the parentheses, so I can take the negation. And we're done. Now we have the final statement. So we've continued, and now our last job is actually to fill out the table. So the headers can kind of be the trickiest part of this. Once you have the headers in, filling out the table isn't as difficult. I'm not saying it's easy. I just mean that, like, once getting those correct headers can be tricky, but once you have them, the last part kind of has more of a routine to it. So you just have to follow some certain patterns. Okay, so we will use the basic truth tables to fill out the truth values of each of the compound statements. That's what I mean by the patterns. So here I'm putting the 3 truth tables we have, the 3 basic truth tables right here, as well as really how you want to think about them. So negation means we just take the opposite truth value, right? So here, negation of Q, we want to take the opposite truth value to everything that was in the Q column. So true goes to false, false goes to true. You don't necessarily want to think about the letters themselves, because again, we're not talking about P anymore, we're talking about Q. So true, negation of true is false, right? So negation of true is false, negation of false is true. So, opposite truth value, this becomes false, becomes true, and so on to get false, true, false, true. Next, we go on to the disjunction of negation of Q and P. So that's this column and this column, right? The disjunction, we can say, is only false if both are false. Now notice I've numbered these just so that we can really identify which columns we're taking in. The numbers, like there being an order to it, doesn't really matter for the disjunction. It will matter when we get to the if-then statements. So that's why I'm just going to start us early on sort of writing out these 1s and 2s. So column 1, column 2, what matters is, can just think of it as true or false, false or true, false or false. Again, we don't need to worry about whether it's P, Q, whatever. It's just true or true equals true. True or false equals true. False or true equals true, and false or false equals false. Or we can remember the verbal statement, only false if both are false, whatever makes the most sense to you. So, here we're going to get, where are they both false? That's what we want to look for. So where are they both false? Well, this is false here, but nope. Neither are false here. This one's false here, but no. So the only time they're both false is right here. So that's what we're getting. We're getting, that's the special row, is where both are false. And it happens to be the 3rd row this time. Okay, so our final one is just a negation outside of parentheses. So it's specifically a negation of this parenthetical, right? So again, we have the negation. Well, negation just changes our symbols, right? So if we were true, it becomes false. True, false. False, true. True, false. So each of these becomes the opposite of what this column had said. So if we were to verbally state what this the truth value of this statement in general, it is only true if P was false and Q was true from the beginning. So in other words, if my simple statements were, I'm wearing a green shirt, and Q is, I have brown hair, right? If those were my original simple statements, then making this compound statement out of them would be true. Otherwise, it would be false. Now, if I asked you to translate this into English, it would be something like, again, using the example I just said, we could say, so we want P to be false here. So P, I'll make that the green shirt. Q is brown hair. So here we would have, it is false that I don't have brown hair or I am wearing a green shirt. It's like, if I said all of that together, would you know that I'm telling you the truth? Probably not, because there's a lot going on in there. There's some double negatives, there's a lot happening. But if you break it down into these pieces, we can figure out, yeah, she's being straight with me. She's saying it in a weird way, but she didn't lie. But if I said something else in there, if I had said, it is false that I am not blonde or I'm wearing a green shirt, well, then I'm actually lying to you. And again, it'd be pretty hard to tell. So the whole point of all of this study is to be able to break down statements like that are kind of confusing and could be manipulative into their smallest components so that you can actually tell what is being said, is it true what is being said, etc. So the most useful, the way to make this useful is especially in situations like when reading legal documents, stuff like that. That's when you run into these situations where they're worded in such a very specific way so that you're never quite sure exactly what they're trying to tell you. But if you break it down using these truth tables, you can figure it out. Alright, so let's try making another one. So this one is negation of P and negation of Q. So again, I'm not going to go through the rules as much this time. We're just going to start with our PQ columns. Again, true, true, false, false, true, false, same as always. But we need to build out our headers. So remember, when we build our headers, we start from direct negations of the simple statements. So both of them, in fact, here have direct negations. But once I have those two direct negations in my column, so negate P, negate Q, I have everything I need to combine them with this AND. So those are our three columns. Now, I'm getting a lot of negations here. First, I'm negating P. Remember, negating just means I take everything and find the opposite truth value. So trues become falses, falses become trues, so this becomes false, false, true, true, right? Direct opposite. Now we take negation of Q is just opposite truth values for Q. So true, false will become false, true, true. So our final thing is our conjunction, right? Our conjunction, again, just like before, it might be a little bit easier not to think of it like this, but to think of it like this, right? Here's our conjunction. So here, if I have false and false, what does that equal? That equals false. Here, false and true, that's false as well. So that's false. True and false, that's false. True and true, that one is true. So whether you want to think of it through the full table or just the statement, only true if both are true, where you just search for the special case where both are true, we can get to this final answer of the only way it is true is if the original statements were both false. So, now let's take a particular verbal statement and figure out the truth value from a given statement. So here we have 1 million is greater than or equal to 1 billion. Okay, so I'm going to break this down into two ideas. The two ideas being 1 million is greater than a billion and 1 million is equal to a billion. Which one of these are either of these true? Well, no, a million is less than a billion, right? We know this. But we're going to break this down. I'm using a sort of easy example just so that we can see how the breakdown works. So 1 million is not greater than a billion, so that one is false, and then 1 million is equal to a billion, also false. The compound statement here can be expressed as P or Q, though, because it is greater than or equal. So that's P or Q. If we substitute the truth values of the statements into the table, we end up in this row. So P or Q becomes false or false, which is false. So that's kind of how you want to think about these verbal statements is you are only looking at one row of the truth table. We no longer care about the whole table because we actually have specific statements that we're making. So we only care about one row now. So if you're given specific statements, you can make what is called a truncated truth table to represent just the row that you are actually present in. So here, let's look at Angelina Jolie is an actress, or Zac Efron is a janitor, but Robert Downey Jr. is not a plumber. So here we have three ideas at play. And notice that there is a not in here. So I'm going to break this down into Angelina Jolie, Zac Efron, Robert Downey Jr. Three ideas, but the Robert Downey Jr. one, I'm going to remove the not from it. So Angelina Jolie is an actress, Zac Efron is a janitor, Robert Downey Jr. is a plumber. Okay. So, how much of this is true? Well, Angelina Jolie is indeed an actress, but everything else is false, right? So we get true, false, and false. So here we're going to write out the compound statement symbolically, right? So we have, here is P, here is Q, we've got this negation of R, right? And then our but is an and, or, and where's our comma? It's before the but oh, wait, I'm not supposed to put, I'm not supposed to put parentheses in certain places. So do we want to put the parenthesis there? Yes, actually we do. We want to put the parenthesis directly right where it is. Remember, we talked about this, that sometimes it can be confusing where we want to put the parenthesis, but we have the P or Q being together like this. This is all fine. That whole statement is then going to be combined with the negation of R afterward. So we get following, right? And if you're confused on the comma thing, take a look back at the previous chapter for a little bit more on comma usage with parentheses, etc. So here we have our statement written symbolically. Okay, so, and we also have the truth tables for our ands and our ors. So if I take this statement symbolically, and I'm just going to translate directly the trues and the falses, we get true or false and negation of false. So true or false, that's over here, true or false equals true, right? So this will be replaced with a true. Negation of false, well, the negation of anything becomes its opposite, so that'll also be true, like so. This will become true and true. Again, we work in parentheses first, and then etc. So now we have true or true, true and true. So I look over at my and table. True and true, that equals true. So I get true in the end. And so the statement is, in fact, true. So it's a bit of a confusing statement saying all of that together, and you might have had some intuition on whether that was a lie or not, but it's always good to be able to break these things down to be sure, because some people make some very confusing statements, but being able to break them down into their simplest form, looking at the real way that truth values work together, the way connectives work together, how do they interact, being able to do that, to break down these more confusing statements, means that it'll be a lot harder to sort of manipulate you with making these very verbose combinations of English sentences, etc. And that's the whole point of studying this.